John Stewart, and my project is testing the efficiency gap as a metric for electoral fairness. First, I should probably get into what the efficiency gap is. The efficiency gap is a formula developed by law professor Nicholas Stephanopoulos, designed to test the fairness of an electoral map. In fact, just last year, the efficiency gap was used as evidence in a North Carolina gerrymandering case to argue that the district map was unfair. The goal of my project was to analyze the distribution of seats won in a series of hypothetical elections to visualize the impact of gerrymandering and, ideally, to demonstrate the effectiveness of the efficiency gap as a method of measuring the fairness of an electoral district map. Based on my research, I predicted that there would be a positive correlation between the distribution of seats and the efficiency gap. The way I wanted to test it was to use a tool from the metric geometry and gerrymandering group to run simulated elections. Each time I ran the program, it would take a starting position of voters and a starting set of district maps and would run 1,000 trials, each trial shifting the borders of the districts by one space. The map was broken up into a grid of 49 squares, 7 districts, each with 7 voters. My results, which you can see in these graphs here, showed that, in general, the district maps trended towards a fairer result. These first two graphs are the distributions of seats won by Party 1, the party represented by clubs on my maps, the number of seats that they won in each election. So, in general, they trended towards winning 2 or 3 seats, which, given that there were 21 clubs in a group of 49 total voters, makes sense, given the percentage. The problem is that you can see in certain cases you can get extreme results. And the goal of political gerrymandering is to force those weird results. In some cases, the party with 21 out of 49 votes could win anywhere from no seats all the way to 5 of the 7 total seats. The second set of graphs shows the average efficiency gap by the number of seats won. Because of the way the math on the efficiency gap works out, in a situation like this, with a set number of votes that are exactly the same between each county, which ideally there would be in real life, but it's not perfectly accurate, the efficiency gap is always exactly the same if the same number of seats are won by a certain party. So every time the clubs won 3 seats, it would get the same efficiency gap. So I took the weighted average of all of my trials to show sort of what your expected result would be with any randomized district, and it actually comes very close to the best scenario of the fair votes. So what those results show is that the efficiency gap and the distribution of seats trend towards a fairer result. In my first district map, which you can see here, the position of the votes was actually favoring one party, the Hearts. Because of that, there was not a great correlation between the efficiency gap results and the distribution of seats. That's because what would be the fairest results were less common than in the second graph. The results also show that the efficiency gap can be an effective tool for identifying district maps that disproportionately represent certain sets of voters, and suggests that the randomized district boundaries do in fact trend towards a smaller efficiency gap, which would make computer-generated district maps a fair method of drawing new district lines. Ideally, I could have taken this project and applied it to a whole state, but I did not have the computer skills to take on a task like this. For comparison, the state whose election data I have downloaded on my computer and was hoping to run it on, Nevada, has just over 3 million voters and is split up into 16 counties. The scale of that is hugely different from what I was hoping, from what I ended up working with because of computer problems. So with my small sample size, it's hard to extrapolate the data to compare it to real world data. The efficiency gaps I generated in my results would be obscenely unfair in a real map, but in my hypothetical maps were fairly normal. But overall, the trends are representative of what I predicted the results would be. Thank you.